Good afternoon, everybody. Welcome back to class. Just a couple of minutes, 3 minutes or so, and then we'll get our meeting underway. But thanks for being here again, and I hope you guys are doing well. Hey, Fernanda. Good to see you. Hi, Megan. Hey, Rose. Hey, Adriana, Alec, everybody there, Lily. Hey, Edie. Hello, everybody. Hi, Nee, Julissa. Hi, Eduardo. Good to see you guys always. Okay. Just a couple seconds, really, and then we'll be good to go. All right, guys. Well, it's pretty much 4. So welcome back again. Good to see everybody. And we're just continuing going through our class. We have a few more weeks of class. The next thing that's coming up, well, first of all, today the third homework is due. So make sure that you do send it to me. I've received a lot of the submissions already. I was away from my computer from like 3 to 4, just the past hour. So those who have sent it to me just today in the last hour or so, not to worry, I'm going to definitely give you your confirmation email, but I'll have to get to it when I'm done with my teaching duties tonight. I have one more class after this, so I'm teaching until about 7 o'clock. And then after that, yeah, I'll go back through my inbox, make sure that I've checked off all the received messages from you guys. Yeah, I don't know what to say, Alec. You know, it's an interesting thing. Some maybe had a little difficulty with it. But the thing is, I don't agree with you. You just got to try harder. Too bad, because this is an assignment that, let me explain something very clearly to you, okay? This assignment, finding fallacies in commercials and stuff, it was not a homework assignment ever before in all of these other years, which I taught this class for like 6 years. The way it always was designed was as an in-class assignment. What I told students to do was this: bring a magazine to class. Come to class with the magazine, and you're going to get one class period to go into the magazine and cut out with scissors, right? Like high school. Cut out with scissors pictures of photographs that are in the advertisements and decide which of the fallacies are in each one. And what I'm telling you is, people would do it in a 75-minute one class period, getting most of the fallacies. So maybe the time pressure helped with people a little bit. Maybe having all this additional time and resources is making it harder for you. Maybe magazines would have been easier for you. I don't really know. But I can't sympathize, because I think I could have done a fine job on it, and other people have done it before in 75 minutes and getting most of the examples. So I just look at you like you just got to reach harder for the higher standard. But anyway, yeah, it's definitely possible to do great on it. If anything, having the resources of YouTube and the internet and all that stuff would make it easier. because there's more stuff there than you could just find in a magazine. But I guarantee you, if you find like 5 magazines, you could sit down with them and do this in 90 minutes. So if you haven't done it already, get some magazines and do it in 90 minutes and send it to me before the end of the day today, because I'll let you turn it in by the end of the day without a penalty. But I have no sympathy for the claim that it's too hard. Okay. Well, anyways, guys, thanks a lot. Thanks for all your hard work. I appreciate your hard work. I know you're doing a lot of things during the semester, but we have different jobs. I'm your professor. You're a student. You got to just do what the professor wants. If they made it too hard for you, that would not be fair. But I know for a fact that I'm fair and reasonable, so not to worry. Okay? Hey, Peachy. All right, so what we got to do now is finish up chapter 12. Well, not all the way finished with it, because coming next is a quiz on next Tuesday. So a week from today, we got another quiz. That's going to be the last of the quizzes for this class. Other than that, the only remaining test is the final exam. So you have one more quiz, one more homework that I'm going to assign next week, and then you have the final exam. So just a couple more things to wrap up in our class. Okay, so then let's get back into chapter 12. You like looking at some of the advertisements. Actually picking one was sometimes the hard part. I mean, yeah, you just have to justify it. You just got to use your mind and write out what the justification is. I'll be pretty generous as long as you can come up with a reasonable explanation for why you thought that fallacy was in the advertisement. But, it's just not a good look. Don't tell your professor that the things are too hard. You're the student. You got to work hard. I mean, it's supposed to be a challenge. Is it too hard? Well, you can make it harder. It doesn't really matter. I mean, you just got to do whatever the professor wants. That's a job the student has to do, and should take pride in it. You should be confident. I think you can do it. I believe you could do it. I know other people have done it. So just believe in yourself. How about that? And you'll be all right. Okay, so good. Let's go back to chapter 12. Science. Okay, so when we were here last time, we just got the chapter started. We started talking about just the definition of science, reasoning from observable facts to testable explanations for the facts. We then talked a little bit about some figures in the early history of science, like, for example, Sir Francis Bacon, Nicholas Copernicus. I briefly mentioned Galileo, kind of in conjunction with Copernicus, because he discovered heliocentrism. But Galileo is also sometimes given credit for that discovery as well. And then I think where we kind of just left off was we talked about the different assumptions behind science. So maybe this is familiar to you if you can remember. We talked about the assumption of empiricism, the belief that most human knowledge comes from observation and 5 senses. We talked about the concept of objectivity, another assumption of science. That's the assumption that there's an objective set of facts that we can actually discover. We can learn about the world as it really is, and that we can get to the truth of it without bias. We talked about the assumption of materialism. Sometimes it's called physicalism. What view is that? Who could tell me about that one, just real quick? What is materialism again? Let's see, who could tell me? Yeah, just let me know. Materialism, please. What's the definition of that word? Everything in the universe is made out of physical matter, including what, Nee? Including what, Nee? Ah, yes, including you and your consciousness. So you're just a bundle of atoms sitting there listening to this lecture. Not just you, though, everything. Everything from the smallest thing to the biggest things in the universe. They're all made out of matter, which ultimately is constituted by atoms. So it's a claim that everything's physical and there's nothing that is not physical. 100% of all things are just physical objects, atoms in the void, as some say. That would be a denial that there's anything about consciousness and experience or perception that is somehow supernatural or non-physical. I guess it would include a denial of the concept of the soul or some consciousness that could exist without a physical basis. Okay, so also I think we talked about the assumption of predictability, which is the idea that the whole universe is orderly and predictable. So established cause and effect relationships will remain permanent and will never change, and they'll be repeatable forever. So like, I don't know, an easy example is how gravity works. You have an object that is released from a freestanding height, it's going to fall to the ground. But how do you really know that that's going to happen next time? That's how it always was before. Well, science just assumes that when we've learned about patterns, cause-effect patterns, and so on in nature, that those don't ever change. That if this is a phenomenon that we've understood now, then it will work in the same way tomorrow and all throughout the rest of time and space. Okay, and then I guess also unity, the assumption that there's an underlying unity, that everything in the universe is kind of unified together so that there should be one set of natural laws that could explain everything. At least that's the hoped for assumption in the future. Okay, now, is that where we left? Did we talk at all about the so-called limitations of science, or did I just call it right there? That's my only question. As far as your notes are concerned, do you have anything that goes beyond this note about unity? So I have another section, and I kind of just forget if it's either right there or just slightly afterwards. But maybe you can quickly tell me. Okay, not to worry, good. So let me just continue from there. The next part of chapter 12 talks about what they call limitations of science. Limitations of science. So these are things that basically count as limitations in the world or concept of science. The last thing you have there, Adriana, is materialism. Well, if that's true, then let me just quickly state a few more definitions before I talk about this. So we're going to get to these limitations of science. Hold that thought. But up here, there were still some like assumptions behind science. So just to make sure that nothing is unclear, we already went through the previously defined concepts of empiricism, objectivity, materialism. Okay, and then the last two are the ones that I guess maybe we didn't get a full enough description of. So let's get to the limitations of science in just a second, but thanks for that. There's also the assumption of what's called predictability. Okay, so this is just the assumption that the universe is orderly and predictable. Not to worry, thank you, Adriana. So the universe is orderly and predictable, meaning that established cause-effect relationships will be repeatable and will hold forever. Okay, so okay, so the universe is orderly and predictable. These established cause-effect relationships will be repeatable and will hold forever. So now let me give you the really full, detailed explanation of this. What the assumption behind science that we're now discussing means, the assumption of predictability, is that the universe, the way it operates, is not random. It's not something that is just kind of haphazard and unpredictable. Once we have determined how a particular law of nature works, the scientific assumption is that that law of nature operates the same way for all time, given the same conditions. So like, for example, you see me holding this marker right now, and all I'm going to tell you is that I'm just going to open my grasp. I'm going to release this marker from my grasp. But I haven't done it yet. So you can now make a prediction. What do you predict will happen? If I just open my hand up, you know, let this marker go, what do you think would happen to it in that case? Easy enough, I think, to predict. That it will fall? Well, how do you know? I mean, you haven't done it yet. Let's find out, okay? Wow, your prediction was correct. How did you know that? How did you know it will fall? How could you tell the future? How do you know the future before it happens? How did you know that that thing would fall if I released it Why? You seem to know that. Who told you it would happen, or how did you figure that? What was your reasoning? What gives you the confidence that it would fall? You say the force of gravity. Okay, now just understand, I'm going to play devil's advocate here for a moment, okay? Well, gravity, you say. So gravity, I guess what? It means that, you know, like massive objects kind of attract each other in the void of space, so it's falling to the surface of the Earth. But how do you really know, though, that gravity is going to work next time? I mean, gravity has worked so far, but how does that tell you it's going to work tomorrow, or even just the next time I release this object? How do you know that in all these millions of years so far, yeah, gravity means that it would fall, but today when I release it, things changed up and it starts to just float off into the sky like a bubble. How do you know that that's not going to happen? Well, you don't exactly have the ability to say that that's 100% certain, but science assumes, now that's why it's an assumption, right? Science assumes that natural laws are not temporary, that they're not just for now, here and now, like for some limited time only, gravity is going to operate, but then all bets are off once we pass a certain amount of time. No, science assumes that the universe is predictable, so the function of gravity would operate the same way at any time, at any place. If there was another, you know, medium-sized planet like this somewhere out there, and there was another object that was suspended above the surface and somehow it was allowed to be released, we imagine, not just imagine, but we would say we presume that the same thing would happen there, because we think that gravity is not just a local phenomenon and not just a temporary phenomenon, but it's permanent and it's thoroughly operating throughout the whole universe. Okay, so science has to assume order and predictability. Otherwise, what would be the point of learning about the laws of nature? We would say, well, we know about them, but who knows what they'll be like tomorrow? Maybe tomorrow, everything we learned about these natural laws will just stop operating that way. Okay, so anyway, we can't really say for sure that the laws of nature will never change, but they so far haven't, and we think that they will always remain the same. So that's another assumption that's built into science. Predictability. Okay, so one more, and that was the assumption called unity. You say it's predictable because of science and their use of scientific laws? No. Science assumes that the universe just really is predictable, but it's an assumption only because we haven't seen the future yet. The future is ahead of us. We're in the present. So whether these laws of nature continue to operate is in a way something that is capable of being doubted. Someone could be a skeptic about the permanence of these natural laws, but science has to assume and does assume that they won't change or that they won't alter. You asked a question about cause. Like, is the universe predictable because of science? The universe existed before science because science is the product of human beings that are investigating the world. But human beings have only existed on the planet Earth for like 100,000 years, and the planet Earth itself is only like 4 billion years old, but the universe is at least 12 billion years old. So your question, in a way, is kind of misplaced. It can't be that the universe is predictable because of science, because the universe exists before science does. People arrive on the scene, humans, life forms, they're trying to figure out what this universe is all about, and now we are saying that we have an assumption, which we think is true, that the universe, which we are like born into as humans, is a thing that's predictable already. Scientists don't make the universe. They explore it, they investigate it, they try and determine how it works. The laws of nature just are what they are, but science assumes that they're permanent and that they're stable. Does this make some sense? Hopefully there, Michael. I just wanted to take your comment, okay? But now we're moving to this, unity. Unity is another main assumption of science, and basically here's the definition. It's the assumption that there is an underlying unity to the universe, such that everything can be explained according to a single set of scientific laws. Yeah, there's an underlying unity of the universe, and if that's so, then everything in it can be explained according to a single set of scientific laws. So, like, basically, and there's a little acronym for this actually, GUT. I'll just put that here. What the letters GUT stand for in some circles of the scientific community is grand unified theory. So we haven't arrived at this so-called grand unified theory yet, but it's kind of like the holy grail of science. It's like the ultimate goal, that someday we will be able to discover all the natural laws, and that we will know them in such a way that they can describe any phenomena, from the largest macroscopic phenomena like whole galaxies or even galaxy superclusters, all the way down to the tiniest microscopic quantum phenomena, tiny little elementary particles and how they operate. Now, today we have not quite got there, because if you know a little bit about the current status quo of physics and theoretical physics, we have Einstein's theory of relativity to explain the operation of large scales of reality. And then we have quantum theory to explain the behavior of the tiny little nanoscale of reality. But we've not yet been able to build a bridge between quantum physics and relativistic physics of Einstein. So there are some like little mathematical and physical contradictions between what the two paradigms say. The goal and the belief, though, of scientists is that someday, maybe in the next century, we'll get a unification of both fields, and then we will have just one elegant set of natural laws that can describe everything from the biggest to the smallest. Basically, the thought is, why would the universe have two different sets of incompatible physical laws? One governing the behavior of the smallest things, another set of laws governing the behavior of the largest things. If it's one universe, you'd think that everything operates according to one set of principles, not more than one. But we haven't got there yet. This is still a goal and a dream that science has not quite achieved to this day. Okay, sorry, Peachy, just going to have to keep moving her around. But next, we're moving on to the second topic that I was gesturing at just earlier. And that is the idea of limitations of science. What are some of the limitations that science kind of has to just agree exist, but you can't really overcome? Limitations of science. Okay, so this part of the chapter I thought was a little bit more philosophical, and it takes a little bit more of like a thorough discussion to fully explain. So I'm not going to have like necessarily a bunch of little easy vocabularies, terms with just a simple definition here. I think it's something easier to talk to you about. But I'll create at least a heading so that in your notes you remember what we mentioned. So one of the limitations of science is just that it assumes the existence of the external world, which I guess can't be proven. Assumes that the external world exists. Okay, so briefly in the chapter 4, when we talked about knowledge, we mentioned this, or no, actually it was earlier than that. It was, I believe, in chapter 1, when we talked about what are qualities of a good critical thinker. We talked about open-minded skepticism, and in passing, I talked to you guys about the famous French philosopher René Descartes, who basically said that if you use the method of doubt, then you'll discover what is certain. And the method of doubt says to assume that things are false if there's any possible way they could be. If they can be doubted at all, just set them aside and assume they're false. With the method of doubt, Descartes says you can't necessarily even trust all the 5 senses and the things that you think you perceive with the 5 senses, because maybe you could be dreaming. So Descartes raises this possibility that everything you think you're experiencing right now, you're just having a big dream. And if that was true, then there wouldn't really be this external world, like where you think you are and what you think is happening, and even just the whole planet Earth could all be like a big illusion that you're just dreaming your way through. So anyway, science assumes, though, that that's not the case, right? Science assumes the point that there is an external world, that you're not just having a big dream, and that you're surrounded by physical objects and that they're real and that they don't just get created by your mind. Now, I say this is a limitation of science, or the book does anyway, because it's something that has to be assumed, but it can't be proven. Because if you were living in a simulation, for example, right now, then the simulation would look just like this. So there would be no way of making a determination from the internal perspective of the observer whether you're having a dream or whether you're having a real life experience. Nonetheless, even though this can't exactly be proven, nobody really doubts it, and science just assumes that, yeah, there is an external world. That there's been an external world that's existed before you, that exists after you, that is independent of your mind. So whether or not you're thinking of it, it's out there and it has a definite objective nature. So another assumption of science. But it's one that I think is easy enough to agree with, because I don't think anybody seriously doubts that there is an external world. If you did doubt that, then you should just drop out of school right now, because it's not even real. But anyway, it is real. Okay, let's just agree on that. So next up, another limitation of science is that it can only study that which is observable. Okay, so this could be also thought of as like a limitation to science, you know, because science is all about using observation to collect data and then try and make theories about how the world works, to observe facts and then provide testable explanations for the facts. We have to use observation. But if there's something that cannot be observed, if there's something that's not even capable of indirect observation, then that would be something really hard for science to gain a full understanding of. So, I mean, if there were such things as like the paranormal, the supernatural, things that could never be physically measured or observed by any means, then those would always remain outside the scope of scientific understanding. Even things that are not necessarily supernatural, if they're unobservable, they would still be hard for science to grasp. Like, for example, we know right now that the universe is expanding. So there is like this powerful expansion of all the material in the universe outward from each other. One theory as to why this is happening is that perhaps because of the force of the Big Bang, all the ejected material keeps just moving out farther and farther from each other. But the weird thing is that you would expect that that force of the expansion of all matter would eventually start to slow down. But in fact, the opposite thing is happening. It's accelerating. So not only is everything moving apart from everything else, but it's happening faster and faster. And it's not understood yet what is the force that's driving this outward expansion. Well, one theory of it is that it has to do with something that scientists call dark matter or dark energy. But it's called dark matter for the exact reason that it's not capable of being even indirectly measured in any way. So if it exists, and if it's the real explanation for the expansion of the universe, it's still something that's going to be kind of shrouded in mystery because it's unobservable. So yeah, another possible limitation of science is that it can only study the things that are at least indirectly observable. And then finally, I don't want to necessarily write this up, but one more limitation of science is that the assumption of predictability that I just mentioned. Some people think, well, that's an assumption that you just can't make. You're assuming that the natural laws can never change. But how can you really know that? Because, you know, we only see as much of time as we've experienced up till this point. How can we really project into the full, you know, maybe infinite future that natural laws remain stable over time? So some people think that's something that you can't logically guarantee. Okay, so then limitations of science. That was the next little portion of chapter 12 to go over. But there's still more, so we're just kind of taking it slow and steady. You say you saw my cat, right? I mean, look at this. This is where I'm lecturing. She's just like sitting there the whole time, belly up. Truly a good kitty, but it's kind of funny to me anyway. Okay, so I want to talk to you guys next about what are some different views or attitudes that people have about the relationship of science and religion. So here we go. 4 views about the relationship of science and religion. Okay, so probably you guys know that there's a lot of discussion that has been made about science and religion not always seeing eye to eye, or even being in conflict with each other, right? So some will say, oh, if you believe certain religious claims, that contradicts scientific information. or on, vice versa. Someone could say, if you're really hardcore scientific in your worldview, then that means you must be denying certain religious points of view. Some people think that the discrepancies or disagreements between science and religion are not that significant. Other people think they are. So here we got to talk to you guys about what are the different perspectives people can have about these apparent clashes between science and religion. So there are 4 of them. The first one is this. The first view would be that science takes priority over religion when the two things disagree or when they come into conflict. So that's one view. Okay, so one option that some have, that some take, is that if science and religion disagree on some point, then the person with this attitude favors the scientific account or explanation. So like for example, take the difference between the theory of evolution and creationism, right? So in science, they say that we humans, the Homo sapiens, have evolved into the current form of life that we have through a long series of gradual changes, and there were other earlier forms of bipedal apes, but it took a while until Homo sapiens emerged from Australopithecus. I'm saying it wrong, but earlier versions of the great apes that descended into man. Anyway, the claim is that took billions and billions of years of a geologic timescale. But according to the religious viewpoint, man was created in the image of God completely, and that did not take more than the first 7 days of creation. So what does a person believe? Because these two things are not saying the same thing. Is it evolution or is it creationism that got us to the point where we have humans? If you hold this viewpoint, then you would say, I'm going to reject the religious explanation and prioritize the scientific one. Or what about the age of the universe or the planet Earth even? In some religious denominations, it is believed that the whole planet Earth has only existed for maybe 6,000 years. But then science says, no, that's not true. We have fossilized remains that we've done carbon dating on, and those show to be millions and millions of years old. So what is the true age of the Earth? Science saying millions of years old. Some religions, not all, but some saying it's just thousands. If you held this view, then you would go in favor of the scientific explanation and reject the religious one whenever they don't agree. Okay? How many days did it take? Well, I don't even should say days. How much time did it take for man to emerge on the planet Earth? According to science, this took literally billions and billions of years, because in the early history of the universe, gas did not accumulate enough to form the stars and the planets that would later on be the source of life on this planet. So, if you're talking to a scientist, it's billions and billions of years after the Big Bang for humans to emerge. But in the Bible, of the book of Genesis, it says that it was all done within 7 days, and on the 7th day, God rested. So these are two different descriptions of the origins of man, or the timeline when we appeared. Some people then, when these disagreements are surfaced, they go in the direction of science. But that's only one view. The opposite is just to the contrary, that religion takes priority over science when they conflict. And so that would be just the opposite, to say that if there is a disagreement between creationism, evolution, genesis of mankind, was there a Garden of Eden or was it just evolution? Then this type of person would say, no, I'm going with the religious answer, and the scientist must be wrong. Maybe their research was incorrect, or maybe they were somehow not able to see the truth or whatever it's revealed in the Bible, but that's another attitude. So some people, they favor science in such disagreements, other people favor religion. And that's just the choice each person makes based on their own judgment and based on what they believe. But there's two other possibilities, okay? The third would be some say that science and religion don't even have conflicts because they're dealing with different topics. So that's another possible view. Science and religion deal with different topics. So basically, if that's the case, so they don't conflict. All right, another idea or viewpoint is that the so-called disagreements, they're not real. There's only the false appearance of having a conflict between science and religion because they're really in their own separate lanes and they're not concerned with the same topics. Some people might argue, okay, well, if you want to get like a physical explanation of how something works, then that's where you look to science. You know, how does photosynthesis work? What are the migratory patterns of these animals? You know, what are the geothermal explanations for the existence of volcanoes, or what are the physical processes that lead to weather patterns or hurricanes, or, you know, the planetary motions, the orbiting of planets around the sun? How does all these things function? If you're looking for a physical cause-effect explanation, then you look at science. And then some people say, but religion has its own separate set of concerns. It's interested in spiritual topics and morality and moral questions like how you'll be judged if you act a certain way or not, and whether you should be trying to protect the condition of your immortal soul if you think there is one. So you could argue that they're not really overstepping each other's boundaries because they're dealing with different topics. If this is like a Venn diagram, this number 3 view would be holding that there's no intersection between the two circles, that they're just in their own separate spheres. Religion is one subject, science is another, but they don't contradict each other. At the same time, though, I know a lot of people prefer to think this way because they don't want to like necessarily offend anybody or contradict anyone. Say, well, if you believe in science, that's fine for you, and if you believe in religion, that's great also, and there's really no reason to disagree or fight. But the problem is that if you actually read, you know, the Bible or any religious scriptures, you're going to see that they do make claims that deal with the same kind of stuff that science talks about. I mean, cosmology is a topic both in religion and science. You know, science tries to explain the origins of the universe, but so does religion. Religion talks about the origins of man, so does science. So it's hard to deny that there are at least some surface disagreements between the two areas when you see some of the things that have been written in both. But nonetheless, many people will hew towards this option. And then finally, there's one more, the fourth. A fourth possibility would be to say that science and religion are compatible, and so they actually agree rather than disagree. Okay, so to some, science and religion, they only look like they have disagreements, but if you are careful enough in the way you interpret religious scripture, that it actually says the same thing as the scientist. So like, this is pretty creative. Someone might say, okay, well in the Bible it says God created the universe in 7 days and everything in it. But science says that no, billions of years passed until mankind first emerged on the planet Earth. Now, how could a person say that although those two things look like they're contradicting each other, that there's a way of sort of finessing the interpretation of the Bible so that these things actually are totally in agreement? Can you imagine how a person might try to justify that point of view? How could that be? If you understand my question. The Bible says 7 days, science says no, 15 billion years. Good, so celestial. It could be like saying that, well, 7 days, it didn't mean it literally. It doesn't mean like 24 hours like a human day on the planet Earth, like how long it takes the Earth to rotate on its axis so that we see the exposure of one face of it to the sun and then to the moon. You know, you could argue that a day it means a day in the life of God or whatever, which could be an arbitrary amount of time, billions of years or whatever. So yeah, there are ways to try and make these two things coherent. Or take evolution versus creationism. You could say that it says God created man in his own image, and it says in evolution that that's not what happened, that it was first, you know, primordial life, and then eventually mammalian life, then bipedal mammalian life, and as we go on further and further, we get to the great apes, and then Homo sapiens. Well, you could say in the Bible when it says God created man in His own image, that just meant He set up the conditions so that the emergence of the beings that would be in His image would eventually occur down the line. So God is like the sort of guiding hand of evolution, and therefore we reconcile the disparities that appear to exist. So anyway, all I'm saying is some people believe that there's a way of interpreting religious scripture or doctrine so that it actually aligns with whatever the scientists discover. The only problem with that is, many people would argue that that's actually kind of post hoc reasoning. So after the scientist makes a discovery, then the adherent of religion tries to make an explanation that deviates from a literal interpretation of the Bible. You might think, well, why was there ever any interest in saying that the 7 days of creation were not actually 7 days? It's not like before the developed understanding that science got, that people were saying maybe a day is a billion years. It's only after science puts pressure on the original religious text that people start opening up the space for a new interpretation. So some might argue that that's a little disingenuous. It's a way of trying to sort of draw the bullseye around wherever the arrow happens to land and say, look, that's exactly what we meant all along. But to some anyway, it might seem like that's weakening the literal interpretation to create space for scientific discoveries, and that was not the initial interpretation prior to them. But anyway, there you go. And let's see a few more comments. So it goes with the idea that everything in the Bible is just a metaphor for what is said by science. Basically, yeah. Here, let me read from the book, and you can also hear a little more of the commentary as they give it. And by the way, this is still going on here. So just so you understand, this is it's almost a distraction to me, but it's fine. Okay, so yeah, here we go. There are 4 basic positions regarding the relationship between science and religion. Number 1, science always trumps religion when there's a conflict. Okay, just so we're clear on the language, the term trump, if it's used as a verb instead of a noun, is a verb that means to take priority over something else, to take precedence over something. So if eating trumps school, then that means that if you had to choose between getting food and getting your grades, then you had to choose food because food is just more important. But to avoid any false association with the current president or something, I'm just using the term takes priority over, which I think avoids that. So anyway, science takes priority over religion when there's a conflict. That's view number 1. Number 2, religion always takes priority over science when there's a conflict. Number 3, science and religion operate in 2 separate and mutually exclusive realities. And number 4, science and religion are concerned with the same reality and are compatible and complementary. So a little more discussion here. Most scientists and Western philosophers adopt the position that science takes priority over religion when there's a conflict between them. This attitude has created antagonism between science and religion, especially fundamentalist religions. Many Christians believe that the Bible is the literal word of God, not only in the religious, but in the scientific sphere. People who adopt this position deny that there is, people who adopt the third position, that they deal with different topics, deny there's a conflict. They argue instead that science and religion each deal with separate and mutually exclusive domains. Science deals with the objective, empirical reality. Religion is concerned with values and a subjective, spiritual reality. Science asks how and what. Religion asks why. Therefore, we can accept evolution without relinquishing our religious convictions regarding the special creation of human beings in the image of God. But one of the problems with this approach is that in some cases, science and religion make claims about the same phenomenon, whether it is the origin of human life, the effect of prayer, the biblical flood, and so on. When these claims are in conflict, logically, they cannot both be true. Now, according to the fourth view, science and religion are dealing with the same reality, and as such, they're compatible. This view is found in Judaism, Hinduism, Islam, and some mainstream Protestant denominations. If Scripture conflicts with the claims of science, then Scripture could be reinterpreted. For example, the creation story in Genesis should be seen as a metaphor rather than taken literally. The scientific and theological enterprises are interacting and mutually illuminating. So anyways, you see all the different possible views there, and now we can move on from that. Okay, so the next part of the chapter talks about the different steps of the scientific method, and then there's some discussion of how to evaluate scientific hypotheses, and then finally, at the end, there's some talk of science versus pseudoscience. So the thing about the meeting schedule that we have coming up into next Tuesday is that I guess I kind of, in a way, gave too many meetings to this chapter 12. So I kind of need to stretch it out a little bit in order for us not to run out of material before we finish on Thursday. So although it's not my normal practice, I was going to kind of like maybe cut this meeting a little shorter than normal, and then that allows us to have a more balanced schedule this week where we'll have about the same amount of time on Tuesday as on Thursday. Because if I just lecture all the way through today, then we're going to get very close to the end of chapter 12, which will make it so that on Thursday it's not a very well-defined meeting. Joshua, here's what you're saying. The clash between science and religion has not shown that religion is false and science is true. It has shown that all systems of definition are relative to various purposes, and that none of them, okay, maybe have more to say there, but I'll wait for you to continue the thought or finish that up. Yeah, I mean, that's one interpretation, Joshua. Obviously, oh, Alan Watts, I see, yeah. So good quoting the well-known kind of Western mystic poet, Alan Watts, very smart, insightful person. All systems of definition are relative to various purposes, and none of them are actually grasping reality. That's one view. You know, if you ask me, I'm a little bit more of a scientific realist. I do kind of hold the assumption that we talked about before of objectivity. I think that, you know, there is an objective world, an objective set of facts. One of the arguments I would give in favor of that perspective is that technology that human beings develop is based on scientific understanding of physical laws, right? So like, how does your microwave work? It's not magic. It works because we understand enough about the electromagnetic spectrum to be able to harness the frequency of wavelength that produces microwaves and therefore can be used and repurposed by us for heating food. How can we build a nuclear bomb? How can we invent radios and televisions that take in waves that we've also been able to propagate throughout, you know, the planet and send in satellite receivers and so forth? So I mean, science, I think, would not work to produce technology if it was just a body of explanations that had nothing to do with reality, right? We were able to build rocket ships that could take us to the moon, and we knew before we had the first people orbiting space what the physical properties would be, that they would have zero gravity and so forth. And like, the theoretical understanding we had was completely matched by the actual outcome when we started to deploy these technologies. So in my view, the great success of human beings in creating medicines, transportation systems, telecommunication systems, even weapons of war, and just all manner of electronics and etc. I think that shows a lot of evidence that science has a very powerful ability to give us a deep and accurate, objective understanding of the world. So I would be a little more inclined towards the view of Watts that you're saying here, Joshua. If science had like just kind of a mixed record, if it was kind of like the old-fashioned alchemy of like the 17th century, where people were just randomly mixing chemicals and sometimes something interesting would happen and other times it wouldn't. But I think that you know, our technological success, especially over the past couple hundred years, gives greater and greater confidence, at least to me, that science really is a great way of explaining facts. You say, right, you're paraphrasing, I know. I'm curious as to your thoughts in regard to there's never truly nothing because there will always be something there to compare nothingness to. Well, that is a whole different can of worms to open. Yeah, I mean, the concept of nothingness, I guess, has to be contrasted against the idea of being. But this type of philosophical discussion is something that's more, I think, found in the French and other continental philosophers of the 20th and continuing on into the 21st century. If you ever have heard of Jean-Paul Sartre, this is a French philosopher who lived from 1905 to 1980, and he wrote a big book called Being and Nothingness. It's a very intimidating book because of the way he writes. He uses a lot of specialized jargon that is you have to really study to fully comprehend. Also, Heidegger wrote a book called Being and Nothingness, not Being and Nothingness, sorry, On Being. So those would be some touchstone books if you really wanted to dive into further studies on that topic. But at the same time, I've always been more interested in the analytic tradition in philosophy, so kind of Anglo-American style of philosophy more than the French and German stuff. And that means I'm a little more, I think, a fan of empiricism and some of these objectivist assumptions that are a little more in the mainstream in the American and British philosophical community. But I think it's all important. It's all important, and we should take the best contributions from all those different traditions. Wouldn't what be analytical? The comparison of being to nothingness? Well, I speak about analytic philosophy in a sense that I guess you would have to learn a little more to understand, because it kind of refers to a tradition in philosophy that prioritizes being logical, being precise, being keeping metaphysical speculation to a minimum, and only being able to say claims that you can define in a clear language. So that kind of precise, logic and science-oriented philosophy is a little bit more my my preference. Coming from UCLA, where I studied in my bachelor's degree, they're kind of the leading analytic school in probably the whole Western university system. So I'm, in a way, a product of my environment, but I also selected UCLA because I already had that maybe way of thinking. I would remind you that as I grew up as a kid, one of my parents was an aerospace engineer, and so I had a lot of interest in science and physics, but at the same time, I had a whole other branch of influence in my family that was for literature and the humanities. So that's kind of why I became this philosopher that also takes an interest in science. So anyways, guys, I'm very happy that we were able to have a little more of an extended conversation, and I always welcome that and invite you guys to pick my brain on any topic, especially when we have a little bonus time like this today. But like I was saying, I do want us to kind of space the meetings out a bit, and so I hope you'll forgive me and not be too upset if I just call our meeting a little bit earlier than normal, you know, about 20 minutes or so early right now, and then we'll finish up chapter 12 next time. So you'll be all good on your notes after that, and then you'll be ready to take a quiz on chapter 12 on Tuesday next week. So for now, anyways, signing off with me and Peachy here. She is just, she's just the best cat. I really don't know. I mean, I'm probably biased, right? I don't know if this is an objective statement, but I've been just blown away by how cute and affectionate these cats are. I mean, I've only had them since June 23rd, and they were like not even 3 months old at that point. So now you guys are really seeing them grow since the semester started back in, what was it, late September. It's been, what, another 12 weeks or so. So, I mean, they've almost doubled in size, I think, since the semester began. Anyways, then, totally off topic, but thanks again, guys. Have a great night, and I will certainly see you back on Thursday. Let me know by email if there's anything else that you need or I could help you with. All right, bye-bye.